So here's what we have for the control module, or the brain module that we're going to put on top of our vehicle or vehicles. At the bottom we have the power plant of the whole thing. So I'm going to look inside there in just a second, but this is the control panels on the front. As you can see right now that, so this is the 5-volt power supply. This is the power supply watching the electricity going out of the batteries. So this is not accurate. What I'm trying to do now is I'm just running this thing. I want to see if I can kill the battery so that I can reset this amp hour rating of this battery, charge the whole thing up, and then reset the number so that I know how much capacity the battery has between what voltage I'm going to charge it to and let it go dead to. So then I can come up with how many amp hours that is. But I need to let this thing go down to where it's kicking out. Right now it's at 13.76 volts. It's going to kick out at 12. So I've used 4-cell lithium in this thing, so the batteries are 3.7 volts each. You can charge them up to 4.2, and you can discharge them to, I think, 2.75. So, but what I want to do is I have the charge, the actual charger inside is limited to 16 volts. So I'm only going to charge up to 4 volts because it's better for the battery. It's just not, there's no need to stress the battery in this thing. I'm not trying to get range. I'm not trying to get every ounce of kilometers out of it. Right now, I mean, I've turned this thing on and off several times. Right now it's been running for 17 hours, and it's only dropped, the smallest amount. Actually, you saw right there, the monitor went off for a second, and now it's not showing any amp draw. I need to address this thing. If I take my phone, if I plug my phone in here to charge it up, so that's what I have this for, and it's running off the 12 volt. This bottom screen now shows the amperage being drawn to charge my phone. But this is supposed to be watching all the power coming out of the battery. If I don't have anything plugged into the 12 volt side over here, then it doesn't count on here, it doesn't register. This half an amp being drawn for 5 volts to run, and what it's running is the Jetson Nano on top, and the LiDAR is plugged in right now, I believe, too, so they're both running. So that's the Jetson Nano, that is the computer that runs right now, running this monitor up on top. So this power pack right now, again, the top volts, this is what it's taking to run the Ubuntu on this computer. So if I hit the enter key, and you see the screen should power up, and you'll see that there's a sudden surge of current while that happens. So this is working. I need to address this down here. Right now it's showing current being drawn because I'm using something out of what, this is on the 12 volt side of it. But I'm only running the 5 volt side. Right now it seems to be accurate. Right now it says it's drawing 0.7 amps out of the battery to get 0.3 amps going to the Jetson. I guess I'm assuming the rest of it is just what it takes to run the system. I guess these, all this stuff going on is probably 0.3 amps of just making everything work. So these numbers seem okay. But here's a problem with well, let me show you on the outside of the box here before I open it up. So on the top here is the Jetson Nano. And on top of that is the RP LiDAR S1. At the back of these I have cutouts here to show the screens for the inside DC-DC converters, and I'll show those in a second. On this side over here I have all the connections. So I have a 8-pin cable coming out of the box over here, and it goes around the back, and these are the 8 pins for it. So there's 2 5 volt, 2 12 volt. There's 2 going to be coming from the relay control in here down to the relay in the power box for the drive. So I want to bring that cable up here as well and do all my connections here. I think ultimately this LiDAR needs to sit up much higher off of there. I also want to have a platform underneath it that's high enough to put an FPV camera. So this is going to be the highest point. It's going to be the highest point. So what I'm working on now is coming up with some sort of platform. But this is going to be really, really visible. So I want this to be kind of really cool. I'm thinking of machining something out of aluminum, something very kind of artistic, sci-fi looking. I'm not sure. That's why it hasn't happened yet. But I can move on. My next goal is to get the LiDAR and the Jetson to speak to each other. How they suggest it happening is this LiDAR comes with a USB adapter that you can plug into the USB here. But the cable's way too long and it's ugly, and I don't want it on the outside of this. So I'm trying to learn how to connect this through UART. And this is all kind of new to me, this stuff. I'm gradually figuring it out. But there is UART connections on the back. Well, hey, let me just turn this around. Let me turn it around this way. So the GPIO pins on the back of the Jetson back here. These two pins up here are UART connections. So I'm trying to learn how all that works. It's hooked up right now. So the LiDAR is powered off 5 volts and ground. The Jetson is powered off 5 volts, actually, off of these ones. This wire goes around and it goes to the plug on the far side. So it's plugged in through the 5 volt 2.1 millimeter plug, whatever it is. And then of course the camera's on the front. The cameras are usually on top of this box, but I wanted them down lower, so I moved them out and I bolted them right to the top of the lid here. And again, the LiDAR, when it's done from the side, the LiDAR is going to sit, up like this someplace with a camera below it. And a GPS antenna up here someplace. So that's the outside of the box. And of course, down here I have different control methods for it, right? Bluetooth keyboard, and a Bluetooth mouse, and I bought a game controller. I saw somebody using a game controller to do data entry on like CD Open and stuff, like picture machine learning using photographs. And because they were outside and didn't have a place to roll a mouse, I thought it was a really good idea to draw. So I'm not, I've never really played with game controllers. I'm not a gamer at all. Trying to figure out how that whole thing works. And I know that, to most people this is second nature. But to me, I've never been a gamer. So I'm going to move this stuff out of the way here. So in the box is done for the most part. These holes in the back here are they go over top of these displays here, and then you can see the voltage and current that's coming out of them. And again, this one controls the 12 volt output in the front corner, and this one controls charging the battery. Again, the battery is deep under here, 4 cells by 6 cells, 2 sets of those in here. So 2 separate batteries. And let me finish off. Down here is the relay to run the whole thing. So what the problem I have now is these 2 digital DC-DC converters out here don't seem to be accurate in their current draw. Because what I've done is I took the wires from both batteries and I put them through the loop, the current measuring loop, the Hall effect sensor, before putting them together. I think I probably caused myself some grief doing that. So they come out of each battery, both individually go through this hole, and then come out and they join together right here. So I think what I need to do is make this connection before they go through this loop. I'm wondering whether something like, and I may not have the exact term here, but the right-hand rule of conductors. So I think maybe because I have 2 wires, and if the current's going through both, one might cancel each other out for this Hall effect sensor. I'm not sure, but that's the only reason I can think that this 5 volt sensor, or this 5 volt power pack, or a DC-DC converter, will increase current when you put something in the 12 volts. When you put something in the lighter socket, this will read it. So somehow they've been talking to each other, and they really shouldn't be. There's not really much connecting the 5 volt side to the 12 volt side, other than the fact that they both hook to this wire from the battery, which is after the current sensor. So I'm going to rewire this. That's what I'm going to do today, but I wanted to give a little bit of a heads up of what's going on here. The next thing here for the top of it is I have an HDMI 10-inch touchscreen that's going to go on here. So to be able to control this whole thing completely individually, I won't need this monitor up top anymore. But I also would love to run this with a solar panel. So I think one of the things I'm thinking about is some sort of solar panel on one side, touchscreen on the other, so it can flip over. The mechanism of it is going to be pretty big, so I would need to really kind of fasten into this base somehow. But wouldn't it be cool that you could, lift something up, flip it over, and it's a solar panel when you're operating, and it takes the touchscreen out of the sun, which I can't imagine is good for it. So it takes the touchscreen, turns it over to the bottom, and the solar panel is up. Then when you want to do some work, when you want to do some, make any changes to it, you can just loosen a couple of wing nuts, flip it over. Now you're not getting a solar panel, but there's lots of battery in here. And then you can do entry, using a monitor that's built into it and capacitive touch. So you'll be able to, do whatever you need to do while you're out with the robot driving around. If you want to take pictures of the sidewalk, you can just do all your controls right up on top here, or using the game controller to enter photographs and running that. So that's where I'm at now. I'm going to spend the afternoon rewiring this a little bit, tying all these wires back in again, and then working on learning robot operating system. So I want to download ROS into this, which is the kind of interface between all of the things, like the obstacle avoidance of the Jetson, with the laser scoping of this, and the speed controller driving the motor, and the steering controller driving the steering. ROS is that thing that kind of joins all those together and allows you to control it in several ways, sending, serial type messages. So that's exciting. That's the part that I'm going to have the most challenge with. Like I say, I like the idea of coding and all that kind of stuff, but I'm admittedly not very good at it. So I'm going to practice that and see if I can get better. And this is going to be the fun part, I think.